Hey guys, this is Eva from Debug Squad. So in chapter 4, we are going to learn about the API at each stage of the compilation process. After learning Babel's compilation process and AST, we have a general understanding of what Babel does. But you still need to learn about the Babel's API, and then you could operate the AST through these APIs to complete the code conversion. So things to take note of here. The API we're learning is Babel version 7. So the API of version 6 has not been divided according to scope, so it's written as Babel-parser. While Babel version 7 has changed to add Babel/parser, the corresponding plugin is also changed from Babel-plugin-something to add Babel/plugin something, but only the package name has changed. The API has not changed much. And we are learning about the basic principle here, so which will not change in the version iteration. So let's go. I'll be talking about what are the API in Babel. And we know that Babel's compilation process is divided into 3 stages: parse, transform, and generate. Each stage exposes some APIs. We are mainly learning about the use of API of these 6 modules: Babel parser, traversal, types, template, generator, and Babel core. So there is Babel/parser in the parse stage. Its function is to convert the source code into AST. And while in the transform stage, there is Babel traverse, which can traverse the AST and cause the visitor function to modify the AST. Modifying the AST naturally involves the assertion, creation, and modification of the AST. And this is where Babel's types comes in. And when the AST needs to be created in batches, you can use Babel/template to simplify the AST creation process. The generate stage will take the final AST and turns it back into a string of code, creating sourceMaps, which requires the Babel/generator module. And the overall functions of Babel are provided by Babel/core, and the overall compilation process of Babel is completed based on the above modules. Plugins and presets are applied. And the API of these modules can be found in document in the official site /Babel parser. You can see in the screens here. And I will also explain each module in details later. So the first module I'll be talking about is the Babel parser. Babel parser is called Babylon, implemented based on Acorn, and adds on a lot of syntax to support parsing of isXxx till ES 2020, JSX, Flow, TypeScript, and other syntaxes. Babel parser can only parse JS code by default. The parsing of non-standard syntax such as JSX, Flow, and TypeScript requires specific syntax plugin, and it provides 2 API, parse and parse expression. Both convert the source code into AST, but what the AST root node returned by parse is wow, the entire AST, while the AST root node returned by parse expression is expression, the AST of the expression, with different granularities. The example is shown in the screen below. And for more details of options, you can read in the documentation and Babel parser options. So in fact, it is mainly divided into 2 categories. What is the input of parse and how to parse. So what's the input of parse? It consists of plugins, allow something, source type. Plugins is specified JSX, TypeScript, Flow, and other plugins to parse the corresponding syntax. Allow something, it specifies whether some syntax is allowed, such as await outside the function, undeclare export, etc. For source type, indicates the mode the code should be passed in. It can be one of the module, script, and unambiguous. Module is to pass the ES module syntax. Script, it do not pass ES module syntax. And lastly, unambiguous, automatically set to module or script according to whether the content has import and export. So generally, we will specify source type as unambiguous. An example is shown here. So when you parse the source code, the source type is unambiguous. Plugin is JSX. So how to parse? By strict mode, by default, ECMAScript code is parsed as strict only if a use strict directive is present or if the parse file is an ECMAScript module. Set this option to true to always parse files in strict mode. Start line. By default, the parse code is treated as if it starts from line 1, column 0. You can provide a line number to alternatively start with. Useful for integration with other source tools. Error recovery. By default, Babel always throws an error when it finds some invalid code. When this option is set to true, it will store the parsing error and try to continue parsing the invalid input file. The result AST will have an error property representing an array of all the parsing errors. Tokens. Adds all parsed tokens to a token property on the file node. Lastly, ranges. Adds a range property to each node. So node start, node end. And when viewing the AST with the ASTExplorer.net, it also supports the setting of parser options. As you can see, it's in the red boxes. The next module would be Babel Traverse. The Babel Traverse module maintains the overall tree state and it's responsible for replacing, removing, and adding nodes. The parse AST is traversed and updated by this module and it provides the traverse method. For example, function traverse parents ops. The first two parameters are more commonly used. Parent specifies the AST node to be traversed, and ops specifies the visitor function. Babel will call the corresponding visitor function when traversing the AST corresponding to the parent. Next will be the traversal process. Visitor is a function that specifies what to do with the AST, with what AST, and Babel will call them when traversing the corresponding AST. And you can specify the callback function of the two stages, beginning of the traversal, which is enter, and the end of the traversal, which is exit. For example, so function declaration called when enter node, enter path state. It's called when exit node, exit path state. And if only one function is specified, that's what the enter stage will call. And enter function is called before traversing the child node of the current node, and exit function is called after traversing the child node of the current node. So first you call the enter function, and then it traverses the child node, and you call the exit function. And the same visitor function can be used to process multiple AST nodes by specifying a series of AST and connecting them with the vertical bar. Example is shown. And in addition, AST also have aliases. For example, various something statements have an aliases for statement, and various something declaration also have an alias for declaration. Naturally, the process of this AST can be specified by aliases. So example is shown here. And the specified aliases, it can be found in the Babel documentations, which I shown a screenshot in the PowerPoint. And each visitor function has the parameters of path and state. So what are these for? Are we talking about path now? So AST is a tree. There must be a pathway in the traversal process, and this path records this pathway. And as shown in the figure, node 1, 2, 3 are 3-layer AST which are related by 2 paths. Path 1 associates node 1 and 2 and records the node 1 is the parent node and node 2 is the child node. Path 2 associates node 2 and 3 and records that node 2 is the parent node and node 3 is the child node. And path 1 and 2 also have parent-child relationship. To such a path object, we have connected the traversed paths. Moreover, the most important thing is that path has many properties and methods, such as recording the parent-child sibling relationship, scope related, types of the AST, operations such as addition, deletion, and modifications to the AST, and also to skip the traversal. So for parent-child sibling relationship, path node, it refers to the current AST node. Path parents refers to the parent AST node. Path get sibling, get next sibling, get previous sibling is the get sibling node. Path find, it finds a node up from the current node. Path get, path set, it's the get or set the property of the path. And there are also scope related. Path scope is to get the scope information of the current node. Type of the AST, path is something. It determines whether the current node is of type something. Path assert something. It determines whether the current node is of type something or not. If not, it throws an exception. So operations such as addition, deletion, and modification to the AST. So path insert before, path insert after is to insert the nodes. Path replace with multiple, replace with source string is to replace the node. And path remove, of course, it's remove the node. For skip traversal, path skip is to skip the traversal of the current node string. Path stop is to end the subsequent traversal. So you can add, delete, and modify the AST. You can also find any node according to the path. And there is scope information. Then it will be it wouldn't be difficult to convert and analyze the code now. So I'll go on to state now. The second parameter state is the mechanism for passing data between different nodes during the traversal process. The plugin will pass options and file information through states. We can also store some shared data during the traversal process through this state. And this is easier to understand. There is a need to transmit data between nodes under different states may do different processings, which is why this parameter is called state. Next module would be Babel types. In the process of traversing the AST, you need to build some AST manually and check the type of the AST nodes. In this case, the Babel types module is needed. For example, if you want to build an if statement, you can call if statement test consequent alternate. To check whether the node is an if statement, you can call isIf statement or assertXxx statement. Ops can specify the values of some attributes, add more constraints, and make more precise checks. So, on the right, if something and assert something may look similar, but they do not function the same. If something return boolean, while assert something throws an exception if the types are inconsistent. All AST builds and assert API can be found in the Babel types documentation. Next module would be Babel template. Creating AST through Babel types is quite troublesome. It needs to be created one by one and then assembled. If there are too many AST nodes, you need to write a lot of code. You can use Babel template module to create in batches. So this module has the following APIs. And these are input in a string and return with the created AST. The difference is that the return AST's granularity is not the same. So for template AST, it returns the entire AST. For template program, returns the program root nodes. For template expression, it returns the AST of the build expression. For template statements, it returns an AST of the build statements array. So some students may ask that they all create AST, why do we need so many APIs? Okay, so it still makes sense to have different APIs because, for example, in the previous chapter, when the expression is executed as a statement, the AST will have a layer of expression statement, as shown in the screen. So the expression that is created with template.ast will be wrapped with a layer of expression statement node, while the AST created by the template expression method will not. So when you know exactly the type of AST you want to build, it's more convenient to use a final grained API. The template also supports placeholders. You can get some placeholders in the template and then pass in the AST node corresponding to these placeholder parameters when calling. So two examples are shown. This is to build AST in batches through templates, but the placeholders are the incoming APIs. It's up to you if you want to add the percentage sign or not. You can add it when the placeholder conflicts with other variable names. Next module would be Babel generator. It turns an AST into code. After the AST is converted, it can be generated as a target code string through the generate API of the Babel generator module. So function, AST object, ops object, code string, and you generate code map. So the first parameter is the AST to generate. The second parameter is options, which specifies some details of generating, such as whether comments should be included in the output or should the output be minified. The third parameter needs to be used when multiple files are combined and generated. This part can be directly viewed in the document. We don't usually use this. So you can see it at the Babel generator document. And sourceMap is commonly used in options. Sourcemaps can be generated when this option is true, which is on the right. Next module would be code frame. Babel's error will be shown in the exact location and can be highlighted. It can also be used when we generate error messages, which is the module Babel code frame. And options can be set to highlighted, whether to highlight, and message, what error, for example, on the right. And the error is generated like this on the bottom left, it's in red color. It's much better to display such an error in the console than to generate an error stack directly. This function of the console generating the code format is called the code frame. So lastly, we have come to Babel code. I mentioned modules such as Babel parser, Babel traverse, Babel types, Babel templates, Babel generator, etc. The function of Babel can be realized through these modules. The module that Babel implements compilation, plugins, presets, and other functions based on these modules is called Babel core. The function of this module is to complete the entire compilation process from source code to target code and generate source map, implement plugin and preset calls. And there are also several APIs. Transform scene, transform file scene, transform from AST scene. For example, these three transform something API starts processing from source code file, and source code AST, and finally generate target code and source map. Options mainly configure plugins and presets and specify what conversion to do. This API also provides an asynchronous version, which compiles asynchronously and returns a promise. Take note that API without scene or async have been marked deserted. That is, transform something will be deleted in the future. So I won't recommend using this. Just use transform something scene and transform something async directly. It's clear whether it's asynchronous or asynchronous. Also, Babel core supports plugin and presets. Generally, we configure the format of objects. In fact, there is also an API to create, that is, create configure item. So, however, there is no differences if you use it or not. It's still more common to write configuration objects directly. So finally, we have come to the end of the chapter. Here's the summary of the 7 modules that I've talked about. So for Babel parser, it parsed the source code, specified the parse syntax through plugin, source types, etc. For traverse, it processes the traversed AST through the visitor function, which is divided into two stages, enter and exit. The specific operation of the AST uses the API of path and can also pass some data through the traversal process through the state. For Babel types, it's used to build and track the type of the AST node, providing the API of something, is something, and assert something. For Babel template, it creates nodes in batches. For Babel generator, it generates AST as target code string, supports options such as comments, minified, sourceMaps, etc. For Babel code frame, it can create user-friendly error messages. Lastly, for Babel code, it completes the Babel compilation process based on the above modules, which can start from source string, source file, and AST. Okay, we have come to the end. So that's all for chapter 4, API in Babel. I'll see you guys in the next video on Babel in action, which will be our first case study together. So if you have any questions, feel free to comment in the box below, or you can contact us directly at supertripled41@gmail.com. Make sure you click the subscribe button and stay tuned for chapter 5 of Babel. See you there!